All right. Yeah. So, almost all the algorithms that you see relies on what is called as, the gradient, right? The gradient. In fact, the definition of convexity, the condition for convexity involves not just gradient, but also Hessian. Okay. But many times, or not just many times, in fact, many classes of problems contains objective functions which are not differentiable. Okay. That means, objective functions may, or around objective functions, or constructed objective function in the intermediate stages of problems may not have the gradient defined. Okay. Not defined. That is, the gradient may not exist at all the points. Okay. For example, if you remember, we talked about this function. What was this function? So this was A1 transpose X plus B1, and this was A2 transpose X plus B2, right? Something like that. So max of this F1 and F2, okay, if you recall, was still a convex function, and you may have such kind of a function for which this point, okay, is not differentiable, right? For example, if you go from this direction, your gradient is A2, and if you come from this direction, the gradient is A1. Okay, so this intersection point does not have a well-defined gradient. So how do you take care of these conditions? How do you solve for such conditions? So there is an idea of subgradient, okay, which says that, well, if I don't have one gradient at a point, if I don't have one direction, one particular defined direction at a point, why not have a set of all possible directions at that point? Okay, so subgradient basically sort of gives you that flexibility, right? Subgradient is defined on those points where a gradient is not defined. Okay, so for example, at this point, right? At this point, okay, so that is the basic idea of subgradient. And how does it come along? So it says the following. I mean, so subgradient, it's a very simple definition, and it comes from the definition of convexity. So if you recall, right? If you recall, convex functions may, we said that the function is a convex if Fy is greater than Fx plus this thing, y minus x, right? For all xy, isn't it? This was the definition of convexity. This was the gradient at that point. Now we are saying that a subgradient, okay, a subgradient, yes? Any question? Okay, a subgradient is exactly this. Just that let's call this subgradient as h. Let's call subgradient as h. Okay, a subgradient of a function, okay, is defined such that this property is still satisfied. Okay, so if this property is satisfied, then h is called the subgradient. Okay, which means I'll take all possible directions, right? I'll take all possible directions h for which this property will be satisfied, then that h is referred to as subgradient. Is that clear? Any question on this?
Sir?
Yeah.
So, sir, basically, instead of calculating from one direction, we will be calculating it from all the direction until we find one condition where this is satisfied, or the point where this is satisfied.
Yeah. So we'll come to excuse me. We'll come to the I'm sorry. We'll come to the estimation of h again.
Okay, sir.
We'll come to that, how to estimate h, how to get one value of h for which you can say this is my subgradient. We'll come to that later. But first of all, the definition of subgradient. So if I give you an h, how will you verify that it's a subgradient? Okay, we are talking about that right now. Okay, and that verification is done by this formula, by this equation. Okay, so you'll say, hey, for this point x, my gradient is not defined. So I will then give you this. I'll say, okay, why don't you try this h, particular h? Then you'll plug that h in this expression, and if the expression is true, then you'll say, yes, h is my legitimate subgradient. Is that clear?
Yes, sir.
Right? So that is the idea of subgradient. Now, let's take an example first so that we'll understand it better. Okay, so can you give me one example of a simple non-differentiable function?
1 by x.
By the way, just to be clear, this subgradient is only defined right now for convex functions, okay, and not for non-convex functions, right? Just
Gradient is not determined. Actually, it is not determined. Subgradient is defined on those points where subgradient.
I think somebody is not on mute. Okay, so subgradient is only defined right now for, we are not talking about non-convex functions. We are only talking about convex functions here. Okay, so that is the caveat. Now give me one example of a convex function, okay, which is non-differentiable.
So mod x.
Mod x. Okay, where is it not differentiable?
0.
0. Okay, so give me two directions of subgradients for this then, because it's a it's in R1, right? This function is in R1. So how does mod x look like? Y is equal to mod x, like this, right? This is y is equal to mod x. Okay, it's not differentiable at this point. Okay, so what are the possible directions of subgradient?
So left and right,
Yeah, left and right. So what is the left differential?
like 1 and -1.
1 and -1, right? So यहाँ से आओगे, you see, right? ये यहाँ का derivative 1 है, slope 1 है, and the slope here is -1. Correct? So basically my two subgradients are -1 and 1. This is my two possibilities of subgradient. Correct? Anybody has a question here? You see, how do you check this? By the way, how do you check this if this is a subgradient? How do you check this? So I have taken this mod x. Okay, again, let me just draw this again. Right? So this is mod x. Okay, how do you say that this direction +1 and -1 are subgradient?
So
This,
basically, we are in the gradient is the differentiation of a function at a it is the differentiation. So a differentiation gives a slope. Here we can see that the two slopes exist. That's why we call them subgradient, and that's how we got, like, it's mod x. So if it would have been mod 2x, then it would have been -2 and +2.
yeah, but how do you say that they are subgradients? What is the condition? What is the how do you verify? Remember this expression?
Yes, sir. So we can take a particular point, like maybe 1 or 2, something like that. And instead of like in the place of gradient of f of x, we'll place h and see the inner product.
Okay. Can we take a more simpler definition? Rohan?
Yes, sir. So I think we can just plug in the values in that equation and check.
Yeah, but what is that equation? We have done this equation before, right? What is the meaning of this equation? Sachin Sharma, what is the meaning of this equation? Okay.
So I have to check my notes. I will get back to you.
Okay. Basically, yeah, Arko, tell me. Can you speak, Arko?
Hello.
Yeah, go ahead.
So this is the first order Taylor approximation of the function,
Okay.
and the point y minus x is the point where we are doing the approximation.
Yeah. Okay.
So I mean, we can do that for any point.
Right. So let's Anup, let's hear Anup. Yes, Anup, go ahead.
That basically this function will always so if we just take the first, like in when x is greater than 0, so if we draw any tangent, then it will always underestimate this function. So
That is right.
basically yeah, so that's why we can say that like this function is that gradient is correct, because it will always underestimate this function.
Thank you, Anup. Thanks. That's absolutely right. So he's saying that, well, let me take a point here. The first order approximation of this function at this point is basically the same line, right? And this line is underestimating the whole thing, right? And this line has a gradient h is equal to 1, right? So then, which means h is equal to 1 is a legitimate subgradient because it is underestimating the whole function. Similarly, if I take a point here, right, and maybe draw a line like this, then this is also underestimating the whole function. And here the gradient is h is equal to -1, which means h is equal to -1 and +1 are both legitimate subgradients because they satisfy this condition of underestimating the function by drawing the line at those points, right? Okay. Is that okay?
So what is the meaning of underestimating?
Underestimating means that all the values of the function lie above that.
Okay, so yeah, thank you.
Excuse me, sir.
Sir, still don't get it. Can you repeat?
Yeah, Siraj.
Yes, sir. So like, sir, we are finding the values of h at a particular point. So we will draw the lines at that point only, or we will draw the line with the same with using a value from the set h and at any point.
We can, we can draw. No, not at any point. You are absolutely right. We are drawing for that point xy. We are saying that for that point xy is h, okay, a subgradient, but that h should cover all the points xy. This is just an example here. Okay.
So h like gradient will h be defined for a particular point, or the h will be defined for the whole function?
No, h. How can h be defined for the whole function? H is only defined for the point where I mean
The gradient is not.
No. H is look. H may not be h. You may not have multiple values for h, multiple vectors for h at every point, right? Because for the points where the gradient is defined, okay, for the
Yes,
points
sir.
where gradient is defined, there is just one h, which is the gradient, correct?
Yes, sir.
So So okay, I get your confusion. You're saying that I'm talking about this point. Actually, I'm talking about this point only. I'm just saying that now I draw a line here. That's what I'm saying, passing through this point. So x and y. So okay. This is my x and this is my y. Is that clear now?
Yes, sir. No, no.
Okay,
The
I get your confusion.
the line will always be passing through that point at which we have calculated the.
That's right. Yeah. And that is underestimating the No. Thanks for the clarification, Siddharth. You're right. I did not spell it clearly that we are only talking about approximation at the point where the gradient is not defined, and y can be anywhere else, right? यही था ना डाउट तुम्हारा सिराज?
Yes, sir.
हाँ, ठीक है. Yeah, Sachin, you have a question?
So I was asking about the underestimation part. You said that all the values will be greater than the this approximation line that is going through this point.
Yeah.
Okay.
So did you attend the previous classes where we discussed this inequality for convex functions?
Yes, sir, but I still have to go through the notes.
No, but you remember, right, that we were talking about this inequality in terms of convexity? Do you remember Taylor series approximation that we had discussed in the previous classes?
Yes, I made the notes, but approximation notes I still have to go through.
No. I mean, you remember or not? That's the first question. So that I can come from, if you don't remember, then I'll start from the beginning. If you remember something, then I'll start from there. So this is what we did. We said that any function, right? Any function can be defined, can be approximated by first order or second order Taylor series. Remember that? And
Right, sir, right.
those Taylor series are an approximation of the function at that point. Okay, by knowing the value at that point. Okay, so if I know fx, if I know grad fx, if I know Hessian of fx and all that, right? So I can approximate that function at that point x based on these things. Now that approximation could be linear, could be quadratic, could be third order, could be fourth order, could be any order. Okay. All we said simply was that for a convex function, the first order approximation is a line, right? I mean, for any function, a first order approximation is line, but for a convex function, that first order approximation is always below that function. What is the meaning of below that function? Which means if a function is like this, then the line is always below this. Can you see this?
Yes, sir. Yes,
all
sir.
these lines, there, the function is always above these lines.
Okay, sir.
This is the meaning of underestimation. Okay. So we are saying that so we are saying that a subgradient h, okay, for a convex function at a point x is such that that approximation, that line, right? Basically, what is subgradient? The subgradient is a direction, isn't it? What is a line? A line basically has a certain value at a point and a certain direction. So also all those lines, right, that approximate that function, okay, at that point, all those lines should be below that function, and the gradients of those lines which are below that function are called subgradients. Is that okay? And
Yes,
mod
sir.
x, for mod x, for mod x, we have at point x equal to 0, we have two lines, +1 and -1. Okay. The question is, can we have third line? Can we have any other line? Now that's my second question to you guys. Siraj, question to you. This is
Yes,
mod
sir.
x, right? ये है mod
Yes,
x.
sir. Yes, sir.
हमने बोला कि there is a line at -1 and 1. Can you tell me if there is another line that passes through x equal to 0 and that underestimates this function?
Sir, x-axis.
X-axis,
Yes, sir. Yeah.
right? Any more lines? So I'm just drawing by black all the possible lines. Any more lines? Sindhu? Any other line?
Only these three. Or
Only
y-axis.
Only these three. There are just three lines that underestimate the function. Shantika, any other line?
Yes, sir, I'm thinking.
So there
You're
are many
thinking-
lines.
Sir, there could be lines whose edge would be less than 1 and -1. So,
So this
then-
line basically, right?
yes, sir.
This
That
line.
passes through x is equal to.
This line, this line, this
So,
line.
sir, there can be infinite of lines having different slopes.
There are infinite number of lines that actually underestimate this function, right? And all of them are subgradients, because that is the definition of subgradient. Is that okay?
Yes,
So,
sir.
so here is the result. Okay, here is the result, and then we'll write the result in its n-dimensional form. The result is this: that actually, let me define what is called as a subdifferential. Okay, not a subgradient, a subdifferential. Subdifferential is basically a convex combination, okay, of all possible lines. H. Okay, So basically I'm saying this following, and this convex combination of all possible lines or all possible gradients is also called a convex hull of a gradient. Okay, so subgradient, basically subdifferential, is basically a convex hull of all subgradients, right? Now tell me one thing. Who should tell this? Rohan again. Are you there, Rohan?
Yes, sir. Yes, sir.
So in the previous example, we had -1 and 1, right?
Right.
Okay. Tell me, what is the convex hull of these two guys? What are the possible, if I give you 2 points, okay, what is that set that comes out of these 2 points, which is a convex set?
So does convex hull mean union or something?
Convex combination of all possible points. अरे -1 और 1 मैंने तुम्हें 2 पॉइंट दिए हैं. Tell me what is that set that you will draw from this, that minimal set, right? Which is basically convex hull of these 2 points. Convex combination of these 2 points. What is that minimum set?
So is it the line segment between these 2 points?
Exactly, right? You see, if I say that, hey, H, this is basically this guy, -1 and 1. Do you see that all possible lines here basically have slope between -1 and 1?
Yes, sir.
Right? And they are all subgradients.
Right.
Right? So we have just done 2 things here. Okay, we said that how to define a gradient at a point where the derivative does not exist, number 1. Number 2, what are the possibilities of finding all such gradients, all such subgradients? So we said that, well, find out as many subgradients as possible and take their convex combination. Once you exhaust using those convex combination, then you stop. Okay, so in this example we said, hey, -1 and 1 ठीक है कर लेते हैं, and उसका convex combination लेते हैं. So we got a line segment between -1 and 1, and we see that now it has covered everything that is possible for a subgradient to be there, right? Which means it's a, that's it, that we have got our subdifferential, right? Is that okay? So basically we have understood the definition of a subgradient and a subdifferential. These are the 2 things.
So I had a
Any
doubt.
question?
So I understood how we prove this, but if we have to prove it mathematically by substituting in that equation, I am not able to understand how we will do that in the Fy is greater than Fx plus gradient of that thing.
No, what are you trying to prove? I don't get it.
So how will we prove this mathematically? Like I understood that.
Prove what? Prove what? That the convex combination of subgradients will be legitimate subgradient?
No, sir. So this part where we were saying that it will be underestimating the function.
But that is the exact definition we started with, right? So we are not saying that we have to prove that it underestimates the function. That is the definition. That is the definition of a subgradient, that it Can you hear me now?
Yes, sir.
Yes, sir.
Where is my laptop? Okay. Yeah. I just don't know what happened. So is my screen visible or what?
No, sir. Now, right now
No,
it is
sir.
not visible. Now
Yeah.
it is.
Now it is.
Okay. Okay. Yeah. So I was saying that where was I? Where did it break? कहाँ break हुआ था?
You were explaining this that sub gradient that from one point to another one.
Yeah. So okay, let me just say it again that question by Rohan, that what do we have to prove? Okay, so Rohan, what we have to prove is this, that if I give you a subgradient, then it follows this first order property. That's it. That is all we have to prove. Okay.
Yes, sir. So you'll be
Now-
giving us an H basically.
We will give you an H, yes.
Okay. Yeah.
And you will have to say that, yeah, this H is a legitimate legal subgradient. So the question that I was narrating, where I probably got lost, is that suppose I give you H1 and H2, and I say that, like, look, I know that these are subgradients, which means that they satisfy this equation. All right.
Yes.
Prove that. Okay. And this question may come in an exam or an assignment. Prove that the convex combination of H1 and H2 is also a subgradient. Then you will prove it from this. Then you will take the convex combination of H1 and H2, plug it in this equation, and verify that that convex combination satisfies this equation. If it satisfies this equation, that combination that is, then you say that, yeah, okay, all the convex combination are subgradients. Got it?
Yes.
And I hope you see that in this case, it is very visibly satisfied. Right?
Yes, sir. Yes, sir. We can just go by that definition that in case of a convex function, the first order approximation is such that all the values of the function lie above it. So intuitively also we can say.
Yeah, intuitively, yeah, but but how do we know that convex combinations also satisfy? Right?
Yes, sir. Yes.
That is a part where you have to prove it. Okay. So let me just give you another example. This example, a lot of people will immediately understand. Okay. Have you seen this function before in your life? Those who have done ML?
Yes, sir. ReLU.
Yeah, right. Let me give you a more generic version of ReLU. Okay. Max of 0, W transpose X. Okay, where W is this direction, sort of. Okay. So max of 0, W transpose X is a function of X, right? Okay. Can somebody tell me if this is a convex function or not? Is this a convex function?
It is
No,
a convex function.
it is a convex function, right?
Yes.
Why Ananya Davas? Why is it a convex function?
Yes, sir. So basically, if we take any 2 points on this, like graphically, we can prove that any 2 points, the line will always lie above this function.
But that's a graphical definition. Give me a more rigorous mathematical reasoning behind it. Why is max of 0, W transpose X a convex function?
So then we need to take double differential, and if double differential is greater than 0, then we can say that. So
you can't differentiate this. No, this is a max function. First of all, is this a differentiable function? It's not differentiable at 0. So you can't take double differential, right?
Yes, sir. So, but we can use the property. so max of two functions. So 0 is one and W transpose X is other. So if both of them are convex function, then like the max will also be a convex function.
That is right. So that is the answer, na? That max of two convex function is convex function. End of
Yes.
story.
Yes,
Right?
sir.
That's it. So the point is that it is a convex function, but it's not differentiable at 0. Okay. So my question to you is, what is the subdifferential of this guy? And where is it used? It is used in, now you see, right? ReLU sort of a thing. It is used in almost every neural network that where ReLU will be used. Okay. So to find the optimization, to optimize that network, you'll have to go through the subgradient definition, and we'll come to that also. But tell me, or not you, not you, Ananya, anybody, tell me what is the subgradient of subdifferential of this function? Debarshi Dasgupta,
Yes, sir.
what is the subdifferential of this function?
Sir, the line segment joining 0 and 1 because slope the
0 and 1.
No, means this 0 and W transpose.
0 and W, just W.
W.
Yeah. So basically, look, there are two functions. One is this F1 and other is this F2, right? What is the slope of F1? 0. What is the slope of F2? W. So basically, all possible convex combinations of 0 and W, right? This is the subdifferential of this function. Simple. Okay?
Yes.
Okay, everybody? Any question?
Sir, excuse me, sir.
Yeah.
Sir, so like first we started with the subgradient and we find out H, but now we are saying that the convex combinations of H are known as subdifferential.
Many H's, yes, many such H. Yeah. Correct.
So basically, in like previously you said that we need to find as many members in the H as possible. So what
Yes.
do you mean by that? Like how is it?
What I mean from there is that if you just find one H, just say yahan pe, right? For this case, what is that one H? Can you tell me what is that one H? Siraj?
So where?
In this example,
yes, sir.
give me one H, one such H.
So
one such direction.
One member of H, na? Yeah,
one member of, no, one such H, one member of grad F nahi, del F nahi. One member of this set.
So 0.
0, right? To this guy, this line.
Yes, sir.
But is this enough? Is this the only member you think?
No, sir.
Then give me another member.
So 0.5.
0.5 कैसे पता? W ना? W तुम्हें पता ही नहीं. By the way, this is so this guy,
yes.
Right? Now everything in between this is also a subgradient.
Yes, sir.
That's it, right? We found it.
So so we need to find some sort of border points of H.
That is
so
right. That is right. Yes. So I have not gone into how do you find that convex hull in a more rigorous fashion, and that's exactly what you do in a convex optimization course. But I'm just giving you the overview of how do you do that.
Sir, so we can say that lines having slope less than W. So these are the subdifferential of F. This function.
Not less than W, because W is a vector. Okay, 0 is also a vector here. But yeah, lines, all the possible slopes between, which are convex combination of 0 and W. Between W nahi hota na, W is a vector. So there is, there's no way to compare two vectors. You only compare scalars. Okay. So therefore we are saying all convex combinations of 0 and W are the subdifferential of this function.
Okay, sir, I got it. Yeah, thank you, sir.
So can you repeat this process for the signum function? Signum is also non-differentiable at 0.
So basically, yeah, let's take why just take signum. Let's take more complicated function, okay, which consists of signum, right? So let's take this function. Fx is this guy. Okay, x is a vector. Where do you get this? Where do you get such an this thing? So we'll see a problem called lasso problem. Okay, lasso problem is basically this, something like this. Minimize, whatever. Okay, close, minimize. So given y, find that x which is minimum, which is closest to y minus, which is closest to this vector y. So y minus x mod square. I mean, one form of lasso problem, but there are many forms. Y minus x norm square. But you also have this additional function in this additional term in this objective function, the one norm of x. What is the one norm of x? One norm of any vector, okay, is basically this guy. What is x of mod of x of I? Basically, this is max of xi and x of minus I. Sorry, minus of xi. मतलब कि अगर if we have a vector x, right? This vector x is less than, let's say, x1, x2 up to xn, then this guy, right, the one norm of this is basically sum of mod of all of them. Okay, this is one norm. Okay, and this clearly, one norm is a non-differential function. Is everybody convinced that this is a non-differentiable function? Are you here?
Yes, sir.
Is it a non-differential function?
Yes, sir.
Right, so let's take this one. Okay, तो इसमें क्या हो रहा है? इसमें सब ग्रेडियंट कैसे निकालेंगे? How will we find the subgradient? So this function is what? This function is this function, right? Okay, so tell me, how will you find the subgradient of this guy? How will you find the subgradient of norm of x1? I just want to give you 1 minute. Look, you have to just find the gradient. We have already done this before. Okay, हमने mod x का निकाला है जब x scalar है, right? यहाँ पे निकाला है. Now I just vectorized it, but it will not change anything. Okay, I want to give you 2 minutes, 2-3 minutes to write something and think over it. Okay, then I'll give you the answer. Then you again go back and think over it. And the signum function comes here, by the way. And the person, I don't know who was asking, but it comes here.
Sir, actually, what is written there in that xi is mod of xi is equal to max of
Xi and minus xi. You agree, right, with this?
xi and minus xi. Okay, okay. Okay, yes.
Sir,
Yes.
sir, when we were doing the mod of x,
Hmm.
we had like it was in the dimension, which is like R1. Right now we are having it in n dimensions.
Yes.
So if we relate to the mod x, then it was the h was coming out to be -1 and +1. Similarly, there will be multiple n points in this, so the combination convex combination from those points would form subdifferential or
Okay.
h.
So yeah, tell me the expression for that. Rashid?
So,
Yeah, go ahead.
so it will be similar to previous only. So there will be 3, like for x greater than 0, it will be 1. For x less than 0, it will be -1.
Right.
And at x equal to 0, I think since both are approaching -1 and 1, so it can be either. And yes, that's what I.
So okay, here is my answer. Okay, let's call this subdifferential S. Okay, and here is my answer. I am saying it is between -1 and 1 for every point of this vector. Are you convinced? Because
yes, sir.
Because if you take the derivative, right, what is that? What is the gradient? Gradient is basically this, right? This, isn't it? So if you take the derivative of this summation operation, okay, everything will be 0 but that corresponding index. Okay, and that for that corresponding index, that subdifferential will lie between -1 and 1, right? Because that's what we have done before, mod of xi. So every coordinate will have a option to pick its value of subdifferential between -1 and 1, and all such combinations of for all coordinates will be a set of subgradients, and the convex hull of those subgradients will be the subdifferential. Is that clear? If it is not clear, don't be surprised. It's not easy to really understand this on day one. So I request you to go back and do this for yourself. And if you're not able to do this, check, I mean, in every machine learning book and thousands of PDFs available online, literally millions of courses available online, right? Subdifferential of a Lasso problem. Okay, it's called Lasso problem. This problem, right? Just check out Lasso, and subdifferential of Lasso will be your, will be like very, very prominently discussed in that in any machine learning course worth its salt. Okay, so just go back and check there. And if you're not able to do this, even after reading this and then trying to find it yourself, we'll come back and do it again. Okay, because this is highly critical. Because when you do take subgradient, by the way, just to tell you one thing, right? You all agree, right, that this is a possible subgradient 0, 0, 0.
Yes, sir.
Rashid, is this a subgradient?
Yes, sir. Yeah.
Right, so it is a possible subgradient. So actually बहुत easy होता है. वहां तो हम लोग ये कर लेते हैं जब real machine learning problems के लिए we just take 0 as the vector 0 as a subgradient. Simple. So basically कहाँ आ रहा है ये आता है जब आपको gradient calculate करना होता है back propagation के लिए, या फिर for your algorithm, right, for your first order descent algorithm. Okay, so to calculate descent direction you have to have a subgradient, and then that the subgradient lies between -1 and 1 for each coordinate, so you take 0 for all of them, right? So it makes your life very simple. Okay, it may not be very good all the time, but you can do that. Okay, so that's just very simple, like a rule of thumb heuristic for such problems. But you should know that you are not obliged to take this only. You can take anything else, as long as it is between -1 and 1 for each of the points. Okay, So that's the idea. Good. So that is, your subgradient.